Whew. All right. I know that last one was hard. Okay, and the last one involved a lot of thought. All right. This one's still going to require a little bit of thought, but it should get a little bit easier because you've been doing a little bit more. You've had the practice now, right? So we're going to start applying this to like some real world problems and what does this actually mean? Okay. So when I take a look at this first problem, it says I need to interpret velocity function. So figure 7.1, which I have right here for you, shows the velocity. So I want to go ahead and I want to label that. So here's velocity. This is probably time. And they describe it here as being the derivative of my position function, which is equal to velocity, which they give us a nice happy function here for. And we need to have a particle moving along the horizontal axis. All right, great. From time equals 0 to 5. So 1, 2, 3, 4, 5. Describe the motion. So if I'm going to describe the motion, what I want to be doing is I want to be describing two things. Which direction it's going and whether or not it's slowing up or speeding down. Speeding up or slowing down. Okay? So let's go ahead and figure out what is happening. So on this first part, I'm moving to the left because my velocity is negative. So I could go find out what this is, but I'm going to cheat, and I'm going to just call this time A. Okay, for time from 0 to t to A. So when time is between 0 and A, the particle is moving to the left and slowing down. How do I know it's slowing down? Because my velocity is getting closer and closer to 0. And then I would say, well, what do I know about for the time frame from A to 5? The particle is moving to the right because now velocity is positive, and because my velocity is moving away from the x-axis, is speeding up. Okay? And that's all you really have to do to explain that. Okay? This next one, okay, see what's next. Okay, suppose the initial position of the particle in example 1 is s of 0 equals 9. What is the particle's position? All right, so we need to have some help here as far as figuring out. They want actual position. So we have to go to physics for a second. And part of our physics says that final position, in order to know where I end up in my final position, I need to know two things. I need to know where I started. That's my initial position. An initial position, that is when t is equal to 0, or whenever t is equal to the beginning of the interval I want. Okay? And I take my initial position and I'm going to add in my displacement, what's called displacement. Displacement is my net movement. What does net movement mean? That means I can move to the left, I can move to the right, but overall, how much did I move in general? Does that make sense? Okay. So for instance, I need to figure out, well, how do I find out what displacement is? For that 1 second even. Okay, because I want to know final position. I know my initial position is 0. At 0, at time equals 0 is 9. I need to find displacement. So what formula do I come up with? Graphically, what am I looking for? Graphically, what I'm looking for is here's time is equal to 1. I'm looking for what is that right there? That tells me I'm moving to the left. So this can be a negative movement, if you will. So I need to find out what that is. So let's go ahead and I come back over here. And I'm going to add that to my 9. So how do I find that area? Well, glad you asked. And this is where I'm going to take this and show you. So my displacement is simply the integral of my velocity for that first second. Oh, so let's go figure that out. So it's the it is now the integral from 0 to 1. My velocity function was, I believe, t squared. Let me go back and look. Yep. Minus an 8 over a t plus 1 squared. Let me just double check on that. Yep. dt. So I can treat this as two separate integrations. This one here of the t squared minus this one here. So that's what I'm going to do because I need to, for solving this without a calculator, I need to do a little bit of work. So if I separate these into two separate integrals, 0 to 1 of t squared minus the integral of dt minus the integral from 0 to 1 of 8 over t plus 1 squared dt. So what I find out is that the first one's easy to do. The second one, I need to do a u substitution. So for the second one, I'm going to say that u is going to be equal to t plus 1. You've done enough of these to see that du is going to equal dt. And so what I find out is that after simplifying, this one becomes 0 to 1. 8 comes on the outside. I have u to the negative 2 du. Oh, but what didn't I change? I didn't change my limits of integration. Okay, so for this part, it's going to become 1 to 2 because I'm plugging in. I got to plug in my values for my limits of integration. Okay, so I raise it up a power. So this is going to be 8. Raise it up a power. U to the negative 1 over negative 1. Evaluated from 1 to 2. Okay. So I go ahead, I plug that in. I find out that that's going to be equal to 8. I'll rewrite this a negative 8, 1 over u, evaluated from 1 to 2. Plug this in. Plug in the 2. I get a negative 4. Plug in the 1 minus a negative 8, which is equal to a positive 4. Cool. And then I need to do the same type of a deal for the other one. When I do the other one, this one's easier. This is just t cubed over 3 from 0 to 1. And then I go ahead and plug that in, and it'd be 1/3. So this total over here is 1/3 minus, don't forget the minus that's there, I had here, which is 4. 1/3 minus 4 is equal to 11/3, a negative 11/3. And there's my answer. For the first second, I went 11/3 units to the right. Okay? Whew, that was a lot of work. Okay? But that's just my displacement. I want to find out what my final position is. All right, well, I don't know what my final position, I'll call it FP, is equal to my initial position, which I said was 9, plus a negative 11 thirds. I add that together, and what do I get? It's 3, 6, 5, and 2, 1/3. That's my new position, which is equal to 16 thirds. Wow. All that work for just that. Yeah. Okay. 16 thirds. That's my new position. Let's sink in for about the steps that we did. We found my displacement, added it to my original one. Now, mind you, the steps for finding displacement were long. All right. And then we want to redo this for 5 seconds. Okay. Well, shoot. How do I do that for 5 seconds? Well, I got to go through the same process. So I'm going to do is I'm going to pause. I'm going to cheat. I'm going to get to a certain spot, and we'll go to the next slide here shortly. But I'm going to magically reappear. Bam! I told you I'd do it here. All right. So I'm just going to quickly explain my work. So this is actually on the next slide. See, there's a box right there. So what you need to be looking at is I set it up the same. This time I want to go from 0 to 5 seconds, right? So from 0 to 5. And this time, so I separated it out, did all the exact same work I did before, except from 0 to 5 here. Instead of being 0 to 5, now it's 1 to 6 in terms of U. Okay. I showed you my plug-in for each of these. Okay, and I know I had to simplify, so I changed 125 over 3 to 250 over 6 minus, and this whole business here with all those negatives, keeping it all straight, comes out to a positive 40 over 6, so 250 minus a 40 over 6 is equal to 210 over 6, which is equal to 35. Again, that's my displacement. So how do I find my final position? Well, my final position again, as I start with my, is equal to my initial position plus my displacement, which is then equal to 44. Great. But how can I repeat this over and over again? What was the process that I was doing over and over again? And that's where I slide this out of the way. And look at this, ugliness that we had to go through. Okay. So this is what this is saying is my position function. I will always have to do this for some derivative like this. Derivative, so I'm going to take my velocity, the integration of my velocity from 0 to t. So this gives me my displacement, is this part. That's what we were doing for those first two. And then adding in my initial position. And that's what we had to do over and over and over again. Now, couldn't there be a way to do this simpler so I wouldn't have to do the integration over and over and over again? Again, glad you asked. So here we go. Boom. So it says use the indefinite integral. So again, here's my function. It says use the indefinite integral to find a solution to this initial value problem. This is going to be a little bit different. So I'm going to start off with an indefinite integral. What does that mean? That means I'm going to have an integral without a limitation. Okay? And I'm going to say that my position function is going to be equal to the integration of my velocity function. So I'm going to go ahead and put that in there. It's going to be the integration of t squared minus 8 over t plus 1 squared dt. And I'm going to go through the same process, right? I do still need to separate these. So I'm going to use the same process of separating this out, which is then going to be equal to the integration of t squared dt minus, and I'm going to do the quick u substitution really quick, u to the negative 2 dt. Oh, not dt, du. And then I do each integration separately. And I find out that this is going to be equal to, okay, this time I want it in terms of t, so I'm going to still have this as t cubed over 3. And technically I'm going to have a plus c from that one. I put this in terms of, and then I have this one over here, minus, okay, 8 u to the negative 1 over negative 1, plus a c from that one. So I simplify this, and I say this is going to be t cubed over 3. Instead of being a u to the negative 1, this would be a plus an 8. What's my u to the negative 1 is t plus 1 to the negative 1. Now my two c's, again, they're just numbers, so I'm going to make them one big giant plus c. And I can go ahead, simplify it just a little bit more. 8 over t plus 1 plus a c. Great. So what does this help me out as? Well, what this tells me is, you know, now I need to go find out, how can I find out what c is? And what I need is, I need this piece of information right here to help me out. So this is all equal to s, but now I need to find out what c is to help me out. So, or to finish this off. So I'm going to go ahead and plug 0 in for t, and my answer should be 9. So I'm going to have this write out that 9 is equal to 0 cubed over 3 plus 8 over 0 plus 1 plus a c. Or 9 is equal to 8 plus a c, or that 1 is equal to c. That's amazing. So what can I do from here? Oh, then I have my formula. And this is what's really amazing about this, is that I no longer have to integrate. I just integrate that one time. I find out that my formula is t cubed over 3 plus an 8 over a t plus a 1 plus 1. And there is my position function. If you want to find out again, does it equal what I found out for the previous one? Go ahead, take the time, plug it in. Okay? You should get the same exact answer. All right? So let's move on. Whew, that took forever. So the last part here is finding the total distance traveled by a particle in example 1. Okay. Now this one, it's gonna, you know, I'm gonna say let's do it with a calculator, and I'm gonna be honest about this one here. I mean, you can do it without a calculator, but you would have to find out where that point is. Remember, I cheated by saying that's A. And you could go find out where that is, but it'd be a real pain in the butt with the equation they gave us. Total distance traveled is something that you need to know. Total distance traveled ignores signed distance. So when it says I travel 3 to the left and 4 to the right, my total distance traveled is 7. My displacement is 1. So when it's asking for total distance traveled, it wants to somehow make all my negative area positive and make all my positive areas stay positive. What function gives me that to where it changes everything to positive? Huh. Well, that might be the integral, because I know I still have to find area. But it's the absolute value of velocity, dt. And you can go ahead and plug that into your calculator and find out what it is, you know, and I'm not going to stop that. All right? Remember to use Math 9. All right, but the main thing here that you need to get for total distance traveled is this piece right here. That is total distance traveled. Okay. You need to include that, okay, for some A to some B. All right. So now, all right. So what I'm going to do is I'm going to pause here, guys. This is getting long, and I don't want you to have to sit here for that long. So what I'm going to say is, hey, take a look at the start of the homework. You should be able to pull off a couple of them and start working with them. All right. And we'll start working. You guys have tomorrow to work on it in class, and we'll take another video and break this one into 2 parts. All right. We'll see you guys in a little bit.